Hey everyone, welcome back to Innovate Yourself, the channel where you decode electronics and embedded systems one project at a time. In today's video, we are diving deep into one of the most powerful and fundamental topics in the IoT and embedded world: firmware development from scratch with ESP32. We will explore how firmware is built layer by layer, from high level application code down to bare metal programming, giving you both a software engineer's and a hardware developer's perspective. So, if you have ever wondered how exactly your ESP32 runs your code, stay tuned till the end. This video will give you a complete roadmap from scratch. Let's start with basic. What exactly is firmware? Firmware is the bridge between the hardware and a software. It's the layer of code that directly interacts with your microcontroller's peripheral, managing GPIOs, timer, UART, Wi-Fi, Bluetooth, and everything in between. Think of it this way: the application layer is like the driver of a car giving commands. The firmware is the transmission, translating those commands into the movement. And the hardware is the car itself. In the case of ESP32, firmware decides how the hardware behaves when your software runs, whether it's turning on an LED, connecting to Wi Fi, or publishing data over MQTT. Now, when we talk about firmware development, there are three major approaches or layers, depending on how much control and flexibility you need. Let's go through them one by one. First, application layer firmware. At the top level, we have the application layer, also known as the high level firmware. This is where most IoT developers start. You typically use environments like the Arduino IDE, MicroPython, or ESP with free RTOs. Here, you're not worrying about low level register configuration, instead, you're writing functional code. And you can see on your screen, this is a demo functional code which it looks like in the application layer. Digital write, the pin number and the value for that, wi-fi.begin with the SSID and password, MQTT client.publish to publish the message over the MQTT client. The underlying SDK takes care of the heavy lifting, configuring GPIOs, setting up stack, managing drivers, and more. This layer is ideal when your focus is rapid development, IoT connectivity, or prototyping smart application. But it's still firmware, just abstracted for ease of development. Second, custom firmware layer, mid level. The second approach is custom firmware development, also called mid level firmware. Here, you move beyond the Arduino environment and start working directly with ESP Expressive IoT Development Framework. In this layer, you have fine control over tasks, memory, interrupts, and peripherals, yet still benefit from the abstraction of free RTOs and ESP libraries. You can write multiple threads, or you can say tasks, configure hardware timers, implement OTA updates, handle SPI, I2C, UART, and create your own drivers. For example, this is a code that you can see, and this is the layer where professional IoT products are built, from smart home devices to industrial monitoring system. Here, your firmware becomes custom, optimized, and scalable. Now, third, bare metal firmware, low level. Now comes the bare metal level, the most fundamental layer of firmware development. Here, you bypass operating systems and SDK abstraction entirely. You interact directly with the ESP32 hardware registers using C or the assembly language. You manually configure the CPU, memory, GPIO, timers, and communication peripheral using their register addresses. Here is the example: hash define GPIO underscore out underscore reg and the address for that, and after that we are setting up the value. So in short, what we are doing is we are just turning on the LED. This is true embedded engineering, where you understand exactly how the microcontroller executes every instruction. Bare metal programming is ideal for real time application, low latency systems, or when optimizing for power and performance. However, it requires deep knowledge of ESP32 architecture, extensor core, and memory mapping. How these layers work together. Now you might be thinking, which approach should I use? The answer depends on your goal. If you're building prototypes or learning, go with Arduino or MicroPython, which is the application layer. If you are developing real world IoT products, use ESP which is the custom firmware layer. And if you are designing high performance or safety critical system, explore bare metal programming. In reality, most professionals work hybrid, using custom firmware for product development and integrating bare metal routines for performance critic tasks like interrupt handling or precise timing. Understanding all three layers gives you complete control, from writing high level code to debugging low level hardware signals. That's what truly defines a firmware engineer, someone who can bridge both the software and the hardware worlds. So, to sum it up, firmware development with ESP32 is not just about blinking LEDs, it's about mastering the full stack from application level logic to custom free RTOS based development, and finally bare metal programming that speaks directly to the silicon. Once you understand this hierarchy, you can build reliable, optimized, and scalable IoT solutions from the ground up. And that's the kind of knowledge that turns you from a developer into a firmware architect. If you found this video valuable, hit the like button and share it with your fellow developers. Don't forget to subscribe to Innovate Yourself for more in depth tutorials on ESP32, IoT, and embedded system. And as always, keep innovating, keep learning, and keep building the future, one project at a time.